For section 2.5, we're going to be looking at how to solve and graph linear inequalities. Inequalities are solved the same way equations are solved, but there's one additional rule. If you multiply or divide by a negative number over the inequality sign, you have to flip that inequality symbol. In other words, if the number you're moving over the inequality symbol is negative, you have to flip the sign. Now I want you to look at these two problems down here. I'm going to do them parallel. On one side, this side over here, I've got a positive 5m and a negative 30. Over here on this problem, I've got a negative 5m and a positive 30. I want you to see the difference. On this particular problem right here, to get the m by itself, I'd need to use the inverse property right here to get rid of that 5. That's 5 times m, so I would use the inverse property and divide by a 5. I'd come over here and divide by a 5. Since the number that I am moving in this case happens to be a positive 5, I don't switch this sign. I realize that this 30 is negative, but that doesn't matter. The only number we look at is the number that's actually doing the moving. Therefore, my answer would be m is less than or equal to a negative 6. Now let's look at this problem over here. In this case, I need to get the m by itself again, but what I'm moving is a negative 5. Now that's negative 5 times m, once again my inverse property, meaning to divide. I'm going to divide by a negative 5. Now what actually did the moving in this case happen to be a negative number. And because that number happened to be negative, I'm going to have to flip this sign, giving me m is greater than or equal to a negative 6. Now I want to look at a much more complicated problem. Not only does this problem involve the distributive property, but it also involves some rationals. Before we start, I want to point out that this negative 2/3 times the constant r minus 3 is one term in and of itself. Remember, the definition of a term is a number times something. In this case, this is a number times a quantity, so this is one term. This is also one term, and of course, this is one term. So as we go through and multiply by our common denominator, which is what we do when we try to get rid of fractions, we have to multiply each term only once. This is a term, so we only multiply the 6 once. This is a term, so we only multiply the 6 once. Now what happens is that we multiply the 6 in the top, and it should create a ratio that can be divided out nicely. Over here we get negative 4 times r minus 3, a 3, and a 3. So if you did your multiplying correctly, remember these rationals should divide themselves out. Now I've still got a complicated problem, but not nearly as complicated. My first step is to multiply in that LCD, giving me negative 4r plus 12, giving me 15 minus 3r. And now I'm going to start putting my like terms together, starting with this 12 and 3. Now since this 12 and 3 are on the same side of the equal sign, I am not going to be using any of my inverse properties. I'm just going to be putting them together. Now I'm going to start moving over the inequality sign, and as we start to move over the inequality sign, we need to start checking to make sure we're not multiplying or dividing by any negative numbers. The minute you multiply or divide by a negative number, you have to flip your inequality sign. So the first thing I did was put my r's together by adding that 4r over, and now I'm going to move my 15 over by subtracting it, giving me negative 6 is greater than 1r, or if you wanted to write it with the r first, it would be r greater than negative 6. Both of these are equivalent. This reads r greater than negative 6, this reads r greater than negative 6. It just depends on your preference for how you want to write your answer. Now we write everything in interval notation, and we graph it in interval notation as well. So I'm going to come over here to the side with my red pen, and I'm going to graph r is greater than negative 6. Now r is greater than negative 6 looks something like this, and if I'm writing it in interval notation, I'm saying what's the smallest thing in this case r can be, what's the largest thing in this case r can be, and this would be my final answer. Alright, let's look at a real-world example of using inequalities. It looks like Martha's got some test scores. Her test scores are 88, 86, and 90 on her first 3 tests. She really wants to average her test scores and get a 90, and she's got a 4th test coming up. What does she need to score on that fourth test to get an average of 90 or above? The minute you talk about an interval, 90 or above, we're talking about inequalities. So let's look at this. I'm talking about two things here. Not only are we talking about inequalities, but we're also talking about averages. And if you'll remember, the definition of an average is you add all of the numbers up and divide by how many there are. What are we adding in this case? We're adding test averages. So we've got her first test, which was 88. We've got her second test, which was 86. Her third test, which was a 90, and the fourth test, which is coming up. We don't know what she got on her fourth test, so I'm going to put an X there. That's my unknown quantity. Now we divide by how many there are, in this case, 4. This represents the average of her test scores. Now, Martha wants the average of her test scores to be greater than or equal to 90. She wants her test scores to be greater than or equal to a 90 average. So what we've done is we've created a problem using inequalities. Now the first thing we need to do, using our order of operations, is simplify the numerator of that fraction. So we're going to take 88 plus 86 plus 90, and we get 264. So I put my like terms together on top of that fraction. Now 264 plus x I can't do because they're not like terms. So at this point I'm going to go ahead and get rid of my fraction by multiplying that 4. Now, I'm multiplying by a positive, so I don't need to change my sign. What I end up with is 264 plus x needs to be greater than or equal to 360. From here, to get the x by itself, we're going to move over the inequality sign. I am not multiplying or dividing by a negative, so I don't need to change anything. And what I end up with is x is greater than or equal to 96. Now what that represents is that Martha needs to score a 96 or better to get an average of 90 on her test, which was what she wanted. If we're writing our answer in interval notation, it would look similar to this. Her test scores need to be between 96 and infinity, if that's possible, for her to get an average of a 90.